Hey, what's going on, guys? It's Mr. Cruze, your Math 10 teacher here. Just providing you a little bit of extra review for your quiz for tomorrow. This quiz is over simplifying radicals using the quadratic formula and factoring to find roots. All right? So just a little bit of practice here. I have like 5 questions I just want to go through real briefly, and hopefully that'll help you complete your review, and then hopefully that will help you do well on tomorrow's quiz. Obviously, as always, if you have questions, email me, tweet me, or message me on Canvas, and I'll be glad to assist you further. All right? Here we go. Determine which two integers the radical is between, then simplify the radical. Okay, so I'm looking at square root of 24. And one of the things I oftentimes think about is this number line, right? Like, I know where 24 falls normally. Like, just plain old 24, 23, 24, 25. Like, I know it's between 23 and 25, right? The question is, well, where does square root of 24 fall? Okay? If those are all square roots instead of just regular whole numbers. Well, square root of 24 clearly falls right before square root of 25, right? And square root of 25 I know as 5. So clearly square root of 24 is close to 5, but not quite 5, okay? Now, what's going the other way? Well, square root of 23, I don't know what it is, but the next closest number I can think of is square root of 16, which is 4. And I know that square root of 24 has to be between those two numbers. So square root of 24 is between 4 and 5. Now, another further explanation that you might be able to come up with, that list we came up with the other day. You might have the list of perfect squares. So you might write like 1, that's 1 squared. 2 squared is 4, 9, 16, all these numbers. 25, 36. And you can keep going. You just take the number and square it, right? And you can sort of figure out where any square root falls. So if I wanted like square root of 44, I know it's between square root of 36 and square root of 49. If I wanted square root of 92, I know it's between square root of 81 and square root of 100, right? So this kind of gives you a list of your perfect squares of your integers, right? So that you can see where these square roots fall. All right, and hopefully that'll help you determine. And obviously square root of 24 falls right in here. So it has to be between 4 and 5. Hopefully that makes sense for you. Now, how do I break it down? Well, somewhere off to the side here, 24, I'm going to break it down into its prime factors. You might break down 24 a little differently than I do, but you should get the same prime factors either way you do it. I would do 2 and 12, and then 2's done. 12, though, can keep going. It'd be 2 and 6. 2's done again. 6 breaks down into 2 and 3, okay? And one of the things I think I suggested in class is as you break a number down, it might be helpful to like cross it out so that you know you're done with it and you're not going to include it in your answer at all. So it looks like 24 is really 2 times 2 times 2 times 3. And then because this is a square root, I'm looking for pairs of numbers. I see that I have a pair of 2's. So that comes out of the radical, okay, as a 2. Now these other two numbers, the 2 and the 3, they don't have any pairs. They're stuck behind inside the radical. And instead of writing 2 times 3, I'm going to write what 2 times 3 is, and that's 6. So square root of 24 is simply 2 square root of 6. Do note that this answer, there's 2 answers here, right? What integers is it between, and how do I simplify the radical? All right. Then we get a little further. Solve the equation. Leave your answer in simplified radical form. So we have 5x squared equals 60. If this problem was 5x equals 60, you would all tell me what to do. You would tell me divide by 5. Well, what's the difference? There really isn't much of one. You're still going to divide by both sides by 5. And if you do, you get x squared equals 12. So normally if it was x equals 12, you'd be done. But this time it's x times x equals 12. I don't want x times x. I want just x. So what we do is we take the square root of both sides. Okay? Square root of x squared is simply x. That's why we take the square root. But now I have to be careful. When I put in my own square root, I have to include plus or minus in front of the radical 12. Because it could be the positive or the negative version. Either of those squared would give me a positive 12. So we have plus or minus radical 12, but I do need to break down radical 12, just like I did previously with 24. So 12 is 2 times 6. 6 is 2 times 3. And you notice the 2, and the 3. If you want to cross off the 12 and the 6, go for it. I have a pair of 2's. That comes out. Oh, don't forget your plus or minus. And then the radical 3 is left behind. So there you go, plus or minus 2 radical 3. Those are your solutions. All right, then we get into like quadratic formula. So this is a quadratic, technically. You could maneuver the 60 over and use quadratic formula. But let's try this one. Notice you are given the quadratic formula. It's given to you on I-step. We'll give it to you for this, all right? So all you have to do is plug your numbers in. So as long as you have y equals your quadratic, technically the y becomes 0 because we're solving for zeros, right? But now we just need to find a, b, and c. And a, b, and c are simply the numbers, the coefficients, in front of your 3 terms. Okay? So a is 25, b is negative 20, and c is 1. So now I just start plugging things in. X equals negative b. Since b is already negative, that becomes positive. Plus or minus square root of b squared minus 4 times a times c all over 2a. I'm literally just plugging numbers into the formula. Now the real hard work begins. You just have to simplify this. So negative 20 squared. Well, a negative times a negative is a positive. So 400. And then negative 4 times 25 times 1 is a negative 100. All over 2 times 25 is 50. Okay? I know these numbers look big, but trust me, this will work out okay. All right. Next step, 400 minus 100. So we get 20 plus or minus radical 300 all over 50. And then now that pesky radical 300, that's not one of our perfect squares, okay? So 300 I'm going to have to break down, maybe off to the side here, 300. Try and break it down into nice, neat numbers if you can. One thing I notice is it's 3 times 100, right? Well, 3 is done, but the 100 breaks down into 10 times 10. Now, let me show you a little Mr. Cruze shortcut here. 10 and 10, that's actually a pair of numbers. I know it's not quite broken down fully, but that's a pair of numbers. You can stop there, okay? It now becomes 10 radical 3. So this is 20 plus or minus 10 radical 3 over 50. It really pays to recognize that 300 is 3 times a perfect square. Okay, that really helps to notice that. Now, here's the deal. I can't combine 20 plus 10 radical 3. Like, I can't combine those into a single integer. Okay, if it was 20, now, please do recognize this. If it was this, 20 plus 10 over 50, sure, I could do 30 over 50 and 10 over 50, right? I could add and subtract and get all that stuff. But it's not, so I can't really combine the top any more than I already can, okay? But there is one little thing I can do. If these 3 numbers, the number in front of the plus or minus, the number in front of the radical, and the number in the denominator, if all 3 of those are divisible by the same number, I can actually divide all 3 numbers by that number. So what goes into 20, 10, and 50? 10. So I can actually divide all of these by 10. Every single one of them. 20 divided by 10 is 2. 10 divided by 10 is 1, which I don't even have to write. The radical 3 remains untouched, and the bottom becomes 5. This 1, you don't have to write it if you don't want to. Just make sure that you have the square root of 3. There's your answers. Like I said, sometimes, guys, like it'll come out to be something like this. And in that case, you do want to do 5 over 5 and negative 1 over 5. You would actually add the 3 and subtract the 3. But the problem is it's a radical 3, so I can't do that. This is an irrational answer. Okay? If they were rational, great, I could do it, but because it's irrational, I can't. All right, last couple, factoring. You guys really seem to like the factoring, so hopefully this will work for you. I put 2 types on here. I tried to pick the most common just so that we can see it. So, solve by factoring. Well, the first thing you always want to look for is look for a GCF first. Okay, always look for a GCF when you're asked to factor first. It'll make your life so much easier. Replace y with 0, and then ask yourself, hey, 100x squared and 25, do they have a greatest common factor? And it turns out they do. They both have 25. So if I pull out a 25, what times 25 would give you 100x squared? And that would be 4x squared. And then what times negative 25, what times 25 would give you negative 25? And that's minus 1. So now we have our GCF out of there, okay? Now we have to worry about this guy, 4x squared minus 1. Well, I notice that this is a perfect square, and this is a perfect square, and they're separated by subtraction. This is what we call a difference, because of subtraction, of squares, because they're both perfect squares. So here's a shortcut. What is the square root of 4x squared? Well, square root of 4x squared is 2x. Okay, square root of 4 is 2, square root of x squared is x. And what's the square root of 1? Well, the square root of 1 is 1. But to multiply to a negative, these signs have to be opposite. So that's our little shortcut. And now we just set everything equal to 0. Now, technically, you should still set the 25 equal to 0. However, 25 will never equal 0, so you really don't even have to do that. Okay? Set your factors equal to 0, though. You'll notice that your answers will be the same number, just opposite signs. Okay? In a difference of squares, that will always happen. So we get 1/2 and negative 1/2. You could always plug your answers back into the original equation if you want to check your answers. All right, last one. Y equals 3x squared plus 5x minus 2. Any greatest common factor there? Well, I see 3, 5, and 2. Nope, nothing going on there. So replace y with 0. And here's what we're going to do. We're going to do the Hensley method. We're going to drop the squared like it's hot. So just get rid of it. 3x and 3x. Okay, we'll deal with that part later. Now, I also need to crank the AC. Multiply the first coefficient by the last coefficient. So 3 times 2 is negative 6. I need two numbers that multiply to negative 6. And those same two numbers have to add up to a positive 5, the middle number. So you have to kind of go through your brain and think, okay, to multiply to a negative, one has to be positive, one has to be negative, but they add to a positive, so the bigger number has to be positive. And it turns out it would be negative 1 and positive 6. They multiply to negative 6, and they add up to 5. So then this minus 1 and that plus 6, I'm just going to write them right in here. Okay? Now, a little shortcut. Remember how earlier I said this wasn't quite right? Because 3x times 3x is not 3x squared. We're 3 times too big, so something's going to have to reduce here. I noticed the 3x and the minus 1, I can't divide any of those by anything. But the 3x and the 6, I can actually sort of divide by a 3. And if I do, I get the proper factorization, which is 3x minus 1 times x plus 2. You can always FOIL that back together if you don't believe me. And last but not least, we set those equal to 0, and we solve. So this gives me, let's see, x equals 1/3. And this one gives me x equals negative 2. There's your answers. All right, I hope this was helpful. If it was, great, and I hope you do well on your quiz tomorrow. If you have any other questions, please email me, tweet me, message me on Canvas, or stop by and see me in the morning, all right? Good luck studying.